Hello and welcome. Today we'll be doing AC sweep. We know the components such as inductor capacitance and MOSFET BJT diode. Output depends on the frequency. For this purpose, we can AC sweep the output to see the changes. Today we'll be building a circuit and AC sweep it to see the various changes. You can also use the AC sweep to find the resonance of a circuit. So let's build a small circuit. So as a source, take VAC. Now followed by a resistor in series, then a capacitor. I have rotated it using Ctrl R, and for the purpose of simulation we need to set a reference node. For that purpose we are choosing ground. Now for wiring purpose we are using this wiring tool. So now the wiring is complete. Let us save the file. Now for the AC source, double click on it. Just change the AC magnitude or AC mag parameter. For example, for this purpose I am choosing the value to be 5. And the capacitor value I am choosing it to be 10 micro. Now press OK and press save. I want to see the change in output voltage across the capacitor. Now before diving into the simulation, try to look at these things first. For capacitance we know that reactance is equals to 1 by omega c. So we can say ZC of the capacitance or the impedance of the capacitance would be inversely related to the frequency, and as VC or the voltage of the capacitor is proportionally related to the impedance, so voltage of the capacitor is inversely proportional to frequency. So as we will increase the frequency, the voltage across the capacitor should fall. So at 0 or less amount of frequency, the voltage should be higher, and the reverse thing will occur for the current across or the current through the circuit. Now let's try to look it. So with the increase of frequency, the voltage across the capacitor should drop. For the purpose of analysis, I'm choosing setup analysis, and this is the first one, AC sweep. By clicking on it, now let's the start frequency from 10 to 1 kilo. Now press OK. Now close. Now save it. Now simulate the file. So our simulation is ready, and you can see with the increase of frequency, which is from 0 to 1 kilohertz, the voltage across the capacitor has drastically reduced. We can also see the change with respect to current. In order to do that, I'm going to use this current marker and place it on this terminal of the capacitor. You cannot put the current marker on a net or node. So see that with the increase of frequency the current is increasing. The characteristics is similar to what we have projected before. So this is an example of AC sweep with a capacitor. Now we can also do the same with an inductor. Just rotated the inductor and placed it here, and now just delete the capacitor along with the every lines or wires I have used across it. Now let's put the current marker at this inductor node, and now the circuit has changed. Let's put the inductor value to be 1 Henry. Now save this file, and now let's simulate it to see the changes. The circuit has changed. So see, with the increase of frequency the current is decreasing. See that for inductance it was supposed to happen. The current of the inductor is inversely proportional to the frequency, so the opposite shall happen with the voltage across the inductor. So with the increase of frequency the voltage shall rise across the inductor. Now let's see whether it happens or not. Now I am seeing the voltage across the inductor. Now see, with the increase of frequency from 0 to 1 kHz, the voltage across the inductor has rise significantly. So it is as we have predicted. Now for the final setup, I am going to use both RL and L and C. Now let's rotate this one, make a RLC circuit. Now it is a simple RLC circuit, you can see. Now change the value as we have taken before, 10 micro. So these were the values that were chosen. Now let's check the AC sweep again. Let's do the same simulation and see whether we can get the resonance value. Press OK, then close. We are going to see the current across the whole branch of network. So one current goes through it. Now let's press simulate to see whether we can get the current, and yes, we have successfully able to see the resonant. Now in order to find the frequency of the resonance, you can use this toggle cursor, and by clicking on, see that this value here is showing what's the value at the resonance. So it is a very high value, 4.99 milliamperes. Now we can easily see the value is at the resonance peak. So we have found the resonance peak value. Thank you.